So today we're going to talk about angles. An angle is in starting position when the vertex is placed at the origin and the initial side is on the positive x-axis. The other ray that forms the angle is called the terminal side. And I will draw a diagram so you guys can see what this is referring to. So if this is your angle and you are basically starting on the initial side, this is the initial side here because it's on the positive x-axis. And then let's say our angle goes down to, let me grab a different color. Let's say our angle comes all the way down to here. This would be considered the terminal side. It's basically like the stopping point, where this part here would be called your initial side. And then the angle we call theta. So theta is the symbol that we use to represent an angle that we don't know the value of. So initial side is always here on the x-axis where it's positive, and then wherever it stops is called your terminal side. So just to have an idea of the language. So first examples are going to be just kind of going through different angle measurements and figuring out how to draw them in standard position. So when we go to draw these, sometimes we have to do a little bit of work on them. So for instance, this first one is in degrees. And I went ahead and labeled all the axes. So 0 degrees, 90 degrees, 180 degrees, 270, and then 360. So each quadrant is basically a 90-degree increment. One thing just to keep in mind, when you are moving in a positive direction, like this is a positive degree, so positive direction is going to be counterclockwise. Well, if you look at part B, we're doing a negative direction. Negative is clockwise. So different variations. So we want to go 120 degrees. So again, we're starting here at the initial side, and then 90, so plus an additional 30. So let's just put it maybe here. And generally how we do the marking is you start on the initial side and you draw an arc with an arrow pointing, and then you put the degree. So this entire angle would be 120 degrees. If we do the second one, negative means we're going clockwise, so you're actually going this direction. And I labeled the axes with the negative corresponding value, so negative 90, negative 180, negative 270, and negative 360. I want to go negative 200, which we know is a little bit past negative 180. So let's say it's about here. So I'm starting again. This is still my initial side. And this would be a negative 200 degrees. Then they give you the measurement in radians. So what I would recommend, our graph is in radians. And so for radians, you have 0, pi over 2, sorry, my camera's not quite getting it over there. You have 0 degrees, pi over 2 degrees, pi, and 3 pi over 2. Those are your increments. And we are going to convert 9 pi over 4. So the conversion, so you don't have to do this, but I think it makes it a little bit easier. So convert to degrees. So we learned before 9 pi over 4, you're going to do 180 over pi. So remember, when you're doing the conversion, if you forget what goes on top, your pi's have to cancel if you're going to go to degrees. So I can go ahead and cross cancel the pi's. 4 and 180 will become a 1 and a 45. And 45 and 9 will give me a 405 degree angle. Now here's the problem with 405 degrees is it is past our 360. So if you look back at this original one, 405 means we're going to be going all the way around plus some. So generally what we do is then we subtract 360 so that we can figure out what angle it would be close to. So you're going to do a minus 360. and that's going to leave us with a 45-degree angle. 45 degrees we know is halfway between 0 and 90. So again, remember pi over 2 in degrees would be 90 degrees. So you would put your terminal angle. So terminal is where we're ending. Now when you draw your angle measurement, we went around one full time and then just a little bit more. And we are going in the positive direction. So you would go around all the way to there. So you made one complete revolution. So that's 360 plus as an additional 45 will put us at that measurement. So this will be a 405-degree angle. So if you want to stop the video and try the next 3 on your own, you're more than welcome to. I'm going to keep going ahead. So for 315 degrees, this one is not labeled, but we have 0, 90 degrees, 180 degrees, 270 degrees. So we want to go 315. So we know that that's going to be past 270. And again, these don't have to be exactly, they just need to be close. As long as you're in the right quadrant, we're good with that. So that would be 315 degrees. And then negative 600. So negative 600 is way over 360. So we are going to do the adding of the 360. This will give us a negative 240. And then if you do your measurements, so 0, negative 90, negative 180, negative 270, because we're going to go clockwise on negatives. We would start here, we want to go to 240, it's about there, so we'd go this direction, and that would be negative 600 degrees. That would not be negative 600 degrees. We got to go all the way one full revolution. So one full revolution, and then it hits. Let me use a different color. Sorry about that. So one full revolution, so it goes all the way through. That's a 360 stopping right there. And then we need to go that additional amount to get us the additional 240. The next one, you have a negative 5 pi over 6. So again, we should do the conversion on this one. So if we convert negative 5 pi over 6, so you would basically keep the negative there. So 180 over pi. And we can cross those off. That'll be a 30. That's a negative 150 degrees. So negative 150, if this was like negative 90, negative 180. So we would be going to about here and counterclockwise because it's negative. So this would be negative 5 pi over 6, which is the same as negative 150 degrees. The last ones that we're going to work on, so that was just drawing angles and getting used to that. The last little part is on comparing angles. Angles can have different rotations, but have the same initial and terminal sides. These are called coterminal angles. So they will have a different degree, but they will basically start and stop. Okay, so this is your starting point, this is your stopping point. They will start and stop at the same place. The directions say to find one positive and one negative. Generally what we do is we take this amount. If I add 360 to this amount, that will give me one angle that's positive. If I subtract 360, this will give me a negative value. So generally when you're trying to find coterminal, which just means they're like related angles is another way to think of it. So they're like the same angle, but basically you would want to add 360 and subtract 360. So if I just take 225 plus 360, that's going to give me 585 degrees. And if I take that same 225 minus 360, that's going to give me negative 135. If you were to plot these on the same graph, these would be the exact same angle as a 225. Okay, and this will be important later on when we go into sine and cosine values. Here we have negative 150 degrees to start. You're still going to add a 360 and you're going to subtract a 360. This will give you 210 degrees and negative 510 degrees. So all three of these angles are related in the fact that they start and stop at the same place. They just have different rotations. Now, what you add in order to do radians is you want to add 2 pi and subtract 2 pi. And the reason we're adding and subtracting 2 pi is that 360 degrees is the same as 2 pi. So if you did the conversion, these are the same exact value. All right, so when we go ahead and do, now we have fractions, so I know we don't like fractions, but you will have to work around it. So you generally don't make these into decimals, you keep them fractions. So if I do 2 pi over 5 plus 2 pi, so I'm going to show the math once and then you guys should be okay. So put it over 1 so you have common denominators is what we're after, times top and bottom by 5. So then this will be a 2 pi over 5 plus 10 pi over 5. Still 2 pi, just now it has common denominators. So 12 pi over 5, that's our positive value. And then do the exact same, 2 pi over 5 minus 2 pi. We already know what this amount is. It's 10 pi over 5, so just go ahead and plug that in. Like so. Oh, I'm supposed to be subtracting though. So 2 minus 10 will give me a negative 8 pi over 5. So there's a positive answer and a negative answer. If you don't get a positive and a negative, sometime instead of adding 360, you could also add double that. You could add 720. You could subtract 720. So you can do different increments of 360, just like we could double this. We could also add 4 pi. We could also subtract 4 pi. So you might need that on homework because you won't always get a positive and negative. And then our last example, pi over 3. So again, take pi over 3. We're going to add 2 pi, put it over 1. Common denominators times by 3 times by 3. So that's going to give me pi over 3 plus 6 pi over 3. So that's a 7 pi over 3. There's our positive answer. And then we want to do pi over 3 minus 2 pi. But again, you know that's just 6 pi over 3. So plug that in. So pi over 3 minus 6 pi over 3 gives us negative 5 pi over 3. And again, we have our positive solution and our negative solution.